We're near the end. 27. Are you dizzy yet? Okay, sorry. 27. You have two binomials being multiplied. They're right next to each other. Okay, so two binomials right next to each other. This is our term, the FOIL method. First times first. So 2x times 5x is 10x squared. The O stands for outside, so the terms on the outside. 2x times 4 is a positive 8x. I stands for inside, so these terms on the inside of the binomials, that's a positive 40x. And then L stands for last, 8 times 4. The last terms in the parenthesis is a positive 32. Check yourself that you combine like terms. It's a good sign you're doing it right. If the middle two terms combine, that usually happens. 10x squared plus 48x plus 32. Moving on. 28. Oh no, 27. Two 27s. Oh my gosh, that's weird. Just tricked you into doing more problems. Now, 27, I challenge you to write it out. This isn't a exponent problem where you multiply all the exponents because of the minus sign right there. If all those numbers and letters were squeezed together, then that's what you would have, but that ain't the case. Here's how I'd want you to think about this one. This is the same as 3a minus 9b times 3a minus 9b. That's what it means to square something. Multiply it by itself twice. Now you're looking at a similar problem where we're going to do FOIL method, or might be called double distributive from where you're from. First times first. 3a times 3a is 9a squared. 3a times negative 9b. 3 times negative 9 is negative 27. A times b, you just have to list it as a, b. I for inside. Again, another negative 27. I'm going to list ab because I'm multiplying a times b. I like listing it in alphabetical order. And then negative 9b times negative 9b is a positive 81b squared. Looks like I can combine the things in the middle there. 9a squared minus 54ab plus 81b squared. Boom. And you might be doing a double distributive method or something similar to the Punnett square. All those ways work. So that's what we're looking at for the second to 27. And we get to 29. Skip 28. Now 29, again, different methods you can use, but you're doing the same thing. You're going to be multiplying all these things. Honestly, when it's a 2 by 3, make a little 2 by 3 box to make sure I multiply everything times everything. You can do the same thing if you're doing your similar to a FOIL method, but everything's got to be multiplied by everything. So I got 4x plus 3 on this side, 2x squared minus 3x, and a plus 6 here. I'll fill in my boxes now. 8x to the third, because I have an x times x to the third. Let's see here, 3 times 2x squared is 6x squared. 4x times negative 3x is negative 12x squared. 3 times negative 3x is negative 9x. 4x times 6 is 24x. And 6 times 3 is 18. It's a good sign if your terms that are diagonal from each other are similar. That's just kind of a good sign. I combine like terms, 8x cubed minus 6x squared plus 15x plus 18. Now that was fun. 30. Brown squirrels and black squirrels. Black squirrels, my favorite animal ever. Biologists modeled the populations in thousands, so that's a lot of squirrels, with the following polynomials, where x is time in years. So there's this many brown squirrels, and there's this many black squirrels. What polynomial models the total number of brown squirrels and black squirrels? When I see that word total, to me it's saying, well, I'm going to add them. So you do add those two numbers. And remember, when you're adding polynomials, it's really all about combining like terms. My first column, I would get 12x squared. The exponents don't change when I'm combining. This one I would get positive 2.2x. And in this third column, I would get a positive 12.1. And in the trickiest of trick questions, this is answer E. Gotcha. But seriously, this is the answer.